I am Dr. V. V. Kamesh, Professor of Mechanical Engineering, Aditya Engineering College. Now, today we will like to discuss about the groupless criterion for the plane mechanisms and number synthesis. So, first we need to know what is meant by number synthesis. In a particular kinematic chain, generally we refer to K chain. In this kinematic chain, we are having links, we have the joints. So, these two are being paired. So, in the links we are having many varieties, binary link, ternary link, quaternary link like this, and in the joints also again binary joint, ternary joint, quaternary joint, etc. will be there. So, the pairings, screw pairs and rotary pairs, sliding pairs or prismatic pair, you call it as spherical pair, like this we are having different pairings. These are called kinematic pairs. By means of all of this, so number synthesis will say what is the relation between the number of links and what is the number of joints and how they are being interlinked with your degree of freedom. That means degree of freedom, already we know very well, the degree of freedom means the number of inputs you have to give to move your robotic manipulator or not only robotic manipulator, any application. So, number of input parameters we need to give, even if it is 12 link, 1 degree of freedom or 10 link, 3 degree of freedom, anything may be. We need to give sufficient inputs related to degree of freedom only. So, for this, out of the 12 links, we are giving one input only. So, out of the 12, one has to be grounded. Other 11 links, any one of the link can be given the input. Other links, we are observing what is the output at a particular links. And here, 3 degree of freedom. That means we need to give 3 inputs. So, the 3 links we are giving the input parameters, 1 link may be ground. So, out of this 10, 4 links are, 1 is the grounding link and 3 are input links. So, 6 links we are able to observe the output, right. And in this case, now we are having what is the number synthesis? For this 12 link, how many degrees of freedom kinematic chains we are able to form? Here the synthesis means creation or generation or enumeration. So, starting with the basic 4 bar mechanism. This is the 4 bar or 4 bar chain. So, this is 1, 2, 3, 4, this is 4 bar. So, this is the 4 bar or 4 link, 1 degree of freedom. From this, we will generate next level. So, 5 link, 6 link, 7 link like this, we will generate by adding another link to this 4th link. So, it becomes 5. If you add 2 links, 6 links, 3 links, 7 links, to the 7 I will add another 3 links, it will become 10 link. Like this, go on increasing, but how they are being connected, the links and joints with the degree of freedom, there are some equations and there are some law. In general, we are calling criterion. Okay. So, in this, the famous scientist of the criterion is groupless criterion. So, based on the number of links, number of joints and the degree of freedom, these particular joints, they can be divided into number of lower pairs, number of higher pairs. If there are no higher pairs, we will make the number of joints to be only the number of pairs which are generating only 1 degree of freedom. So now we will discuss Grobler's criterion. Now we will discuss the Grobler's criterion for plane mechanisms. Earlier we know the degree of freedom or F is equal to, for the plane mechanisms, the general equation is 3 into n minus 1 minus 2 p1 minus p2. That means F is the degree of freedom, n is the number of links, p1 is the number of pairs or the joints which are causing single degree of freedom, p2 is the Grobler's criterion for the plane mechanisms. If it is applied for single degree of freedom, so F is equal to 1, 1 is equal to 3 into n minus 1 minus 2j. So after solving this, 3n 3n minus 2j is equal to 4. So the relation between the number of links and the number of joints is 3n minus 2j is equal to 4. Suppose we are making how many joints are required for a particular kinematic chain with n links. Suppose the n is given for us, n is equal to some 13. If n is given 13, how many degrees of freedom kinematic chain I can form, right? So j is equal to, so 2j is equal to 3n minus 4, that implies j is equal to 3 by 2n minus 2. This equation already earlier we discussed, j must be equal to 3 by 2n minus 2. That means n has to be even number, n has to be even number, right? If n we are saying 13, so j is equal to 3 by 2 into 13 minus 2, so it will become 17.5. So it is wrong. That means if I am saying 13 links, 1 degree of freedom kinematic chain cannot be formed. Cannot be formed. That means for a particular odd number of links given, so 3 by 2 n minus 2 is equal to j. It is valid for single degree of freedom. Then we need to substitute in this equation. So f is equal to make this f to be an integer, n to be an integer and j to be an integer. What we need to do is f is equal to 3 into n minus 1 minus 2j. The number of joints j must be equal to f minus 3 into n minus 1 by 2. If it is given n is an even number or an odd number, so we are having few choices only, either 1 degree of freedom or 2 degree of freedom or 3 degree of freedom, like this. By the observation, for any odd numbered n value, that means n is equal to 5, n is equal to 7, n is equal to 9, n is equal to 11, like this, whatever the n we are having odd number, we are getting a chains with even degree of freedom. Suppose it is the 9 link I am giving. So 9 link 1 degree of freedom cannot be formed because this is an odd number. Even number 2 degree of freedom is possible. 4 degree of freedom possible. Suppose I am giving 8 link. For 8 link, this is an even number. For even, you will get odd number degree of freedom. 8 link, 1 degree of freedom. Suppose I am having 10 link. 10 link, 1 degree of freedom is possible. 10 link, 3 degree of freedom is possible. But 10 link 2 degree of freedom is not possible. Why? Because if we see here, Z is equal to, N is equal to 10. F